In this question, it is given that consider the hyperbola x square upon 100 minus y square upon 64 equal to 1 with foci at S and S1 where S lies on the positive x-axis. Let P be a point on the hyperbola in first quadrant such that angle SP-S1 is equal to alpha where alpha is less than pi by 2. The straight line passing through the point S and having same slope as that of tangent at P to the hyperbola intersects the straight line S1P at P1. Let delta be the distance of P from the straight line SP1 and beta is equal to S1P. Then the greatest integer less than or equal to this is. According to question, this is a hyperbola. P is a point on the hyperbola. It lies in first quadrant. And S is one focus. Other focus is S1. Angle SP-S1. This angle is alpha is given to you. This length is beta given to you, and delta be the distance of P from the straight line SP1, and we have drawn a straight line passing through the point S and having same slope as that of tangent at P. That is, we have drawn a line through S which is parallel to the tangent at P. Tangent at P is this, and delta is this distance, and you have to find the value of beta delta by 9 sine alpha by 2. This full angle was given to you as alpha, and we know that in any hyperbola the tangent at any point bisects this angle. That is, I can say this angle is sure to be alpha by 2, and because this is alpha by 2, this will also be alpha by 2. Clearly, because this length is beta, if I draw perpendicular from focus on this tangent, say this point is Q, angle will be 90. It is clear that S1Q will be equal to beta sine alpha by 2, because this angle is alpha by 2 and this length is beta, hence this length will become beta sine alpha by 2. And we know a property of hyperbola that for any tangent, when I will draw perpendicular from focus to the tangent and perpendicular from focus to the tangent, the product of these two distances is always equal to b square. This property is there in the case of hyperbola also and ellipse also. Hence the given expression this, that is beta delta by 9 sine alpha by 2 becomes beta sine alpha by 2 into delta by 9, and now beta sine alpha by 2. This is beta. This angle is sure to be alpha because in the case of any hyperbola, if I join any point on the hyperbola with foci, the tangent at P always bisects this angle. Because this is alpha by 2, hence S1Q is beta sine alpha by 2. into delta by 9. And now I'm going to use a property of hyperbola that if this is a hyperbola and P is any point on the hyperbola and I draw tangent at the point P to the hyperbola. Say this point is one focus, this point is other focus. Remember that product of length of perpendicular from both the foci, this length into this length, that is if this point is Q, this point is R, then SQ into S dash R product is always equal to B square. The similar property is there in the case of ellipse also. Just for knowledge I am telling you, if this is the ellipse and this is the any tangent and then I draw perpendicular from foci to tangent, this length into this length is always equal to B square. This is valid for ellipse also. And now it is clear that delta is the length of perpendicular from focus S to the tangent, because if I draw perpendicular from focus to the tangent at P, that is this length is sure to be equal to this. Hence I can say delta is the length of perpendicular from focus S to the tangent, and therefore S1Q into delta will become B square by 9, and B square is 64. Hence I get the answer 64 by 9. And greatest integer less than or equal to this is 7. Hence the answer is 7. Let me read the question once again, that consider the hyperbola this with foci at S and S1, where S lies on the positive x-axis. Let P be a point on the hyperbola in the first quadrant. Let angle SP-S1 is equal to alpha, where alpha is less than pi by 2. The straight line passing through the point S and having same slope as that of tangent at P to the hyperbola intersects the straight line S1P at P1. Let delta be the distance of P from the straight line SP1 and beta is equal to S1P. Then the greatest integer less than or equal to this is. That is the meaning of question is, this is a hyperbola, P is some point on hyperbola in first quadrant, and this is tangent at P. S is one focus, S1 is other focus. This length is given to you as beta. This angle is given to you as alpha, and the last thing given to you is, if I draw a line passing through S parallel to tangent, that is I get this line, the distance of P from this line, this is delta given to you, and you have to find the value of this. Equation of hyperbola is this. Let us name SP as lambda, and remember this concept that in any hyperbola, if I join the point P with both the foci, the tangent at the point P always bisects this angle, that is this angle is always equal to this angle. And because this whole angle was given to you as alpha, therefore I can say this is alpha by 2 and this is also alpha by 2. For calculating the value of this, for time being I ignore 9. I have to find the value of beta delta sine alpha by 2. And because this angle is alpha by 2, hence this angle will also be alpha by 2, because these two lines are parallel, that is, this is alpha by 2. And now delta can be written as lambda sine alpha by 2. Keeping this figure in mind, I can say beta into lambda sine alpha by 2 into, note that I have ignored 9 for the time being. Now I have to find the value of beta delta sine square alpha by 2. This is equal to beta lambda sine square alpha by 2, that is beta lambda 1 minus cos alpha by 2. This is equal to, and further to calculate it, I know that for any point P on the hyperbola, mod of SP minus S1P is always equal to 2A. That is, I can say in this question, lambda minus beta is equal to 20, because A is 10 here, and because here point P is lying in first quadrant, therefore it is sure that beta is bigger, hence I can say beta minus lambda is 20. And now it is clear that I can write it as 1 by 4 2 beta lambda minus 2 beta lambda cos alpha, that is 1 by 4. Further note what I am going to do. 2 beta lambda can be written as beta square plus lambda square minus 400. By squaring both sides and taking 2 beta lambda on right hand side, I have got this result. And similarly, this can also be calculated very easily, because this angle is alpha. In this triangle S1P, if I use cosine formula, I'll be getting cos alpha as beta square plus lambda square minus S1 square by 2 beta lambda. Keeping this formula in mind, the value of this becomes beta square plus lambda square minus S1 square. This is equal to 1 by 4 S1 square minus 400, and S1 is the distance between the foci. Distance between the foci is always 2AE. With the help of given equation, we can easily find the value of AE, because we know that E square is always equal to A square plus B square by A square. It means A square E square is A square plus B square, that is 2AE is equal to 2 under root A square plus B square, and 2AE is clearly S1 2 under root plus 64, that is 2 under root 164. Hence, putting this value here, I'll be getting 1 by 4 into 4 into 164 minus 400. That is, you will be getting 1 by 4 into 4 into 64. That is actually I have written 100 plus 64 and I got this result. That is equal to 64. Hence we have calculated the value of this as 64. Therefore the value of this becomes 64 by 9. And therefore the greatest integer less than or equal to this will become 7.